What's up, guys? It's Mr. Bringle, and today we're going to be talking about Newton's second law, equations to guide thinking, concept builder from physicsclassroom.com. And what we're going to do is just go through a couple questions of each level here. Maybe not all 24 questions, but we'll do maybe about half of each of these. Okay, so this says an object has an acceleration of 18 meters per second squared. If the net force acting upon this object were doubled, then its new acceleration would be. Okay, so the first thing here is that you have to understand that this is the equation that we're using. Acceleration is equal to net force divided by mass. Okay, so it's important that you understand that net force and acceleration are directly proportional, meaning that if I increase the net force, I'm also going to increase the acceleration. Okay. And likewise, if I decrease the net force, then I would decrease the acceleration. And that should make sense because the net force is in the numerator. So for instance, if I have an equation like 10 is equal to 20 divided by 2, and I increase the number in the numerator to be 30 divided by 2, well, then obviously the answer has also increased, right? And even more so, if I, let's say, double the numerator and it becomes 40 divided by 2, then I end up doubling the answer, okay? And if I cut the numerator in half, so I cut it from 20 to 10 divided by 2, then I'm also going to cut my answer in half, okay? So that's showing that net force and acceleration are directly proportional. Whatever happens to the net force, whether you double it, you cut it in half, you triple it, you third it, it will do an equivalent change for the acceleration. Now, mass is inversely proportional to acceleration, meaning that if I increase the mass, I will actually decrease the acceleration. And vice versa, if I were to decrease the mass, I would increase the acceleration. Okay, so let's look at that, basically that same equation there. Let's just say that 20 divided by 2 is equal to 10. And if I increase the mass, let's say I double the mass, so now it's 20 divided by 4. Well, my answer here is 5. I've doubled the mass, I cut the acceleration in half. Okay, or let's say that I cut the mass in half. So I go from 2 to 1. Well, now the answer has been doubled. Okay, so the acceleration is doubled when the mass is cut in half. So those are opposites, and acceleration and mass are inversely proportional to one another. So it says that the acceleration is 18 and the net force is doubled. You can literally just you can make an equation that's equal to 18. It can be as simple as this. 18 is equal to 18 over 1, right? Now it says that we double the net force. So instead of 18, it's now 36 newtons. So this would be newtons, this would be meters per second squared, this would be kilograms down here. So now it's 36 newtons divided by 1 kilogram, which is clearly 36 meters per second squared, right? So that'll be our answer here. And we will go ahead and check it. Excellent. Okay. So let's go ahead and continue. I know that was a little long-winded, just trying to explain how to do the questions, and now we'll move quite a bit faster, okay? So it says an object has an acceleration of 18 meters per second. So again, we could do the same thing. We could say 18 is equal to 18 newtons divided by 1 kilogram here. It says if the mass of this object were tripled with no change to the net force, then its new acceleration would be, okay, so if we leave the net force the same and leave it as 18 newtons divided by, and we triple the mass, so now it's 3 kilograms, well, 18 divided by 3 is going to be 6 meters per second squared. Okay, so we'll go over here, we'll type in 6. So you can see here that we tripled the mass, and it divided the acceleration by 3. So they're opposites, right? Okay, great. Now this says an object has an acceleration of 18 meters per second squared again. And it says if the net force acting upon this object were tripled, then what would the new acceleration be, assuming the mass stays the same? So if we triple the net force, so 18 times 3 is 54 newtons divided by 1 kilogram, then we can see that we're also going to have to triple the answer, which is the acceleration here. So the answer becomes 54 meters per second squared. Okay. All right. So we'll go ahead. Whoops. Go ahead and leave that there. And let's go ahead and move on to another level here. So we'll move on to the master level. We'll do 3 or 4 questions here. An object has an acceleration of 6 meters per second squared. Excuse me. If the net force acting upon this object was tripled, then its new acceleration would be. So it says the acceleration is 6 meters per second squared. Okay. So we can just make any equation that would result in 6. So we can literally do 6 newtons divided by 1 kilogram. Okay. It says if the net force is tripled, so instead of 6 newtons, 6 times 3 is 18 newtons divided by 1 kilogram. We can see that our answer is also tripled. So hopefully you're catching on. Whoops, that's not newtons. I apologize. This right here is going to be meters per second squared. So I hope that you're kind of catching on to the theme here, which is what we talked about at the beginning, that net force and acceleration are directly proportional, and that mass and acceleration are inversely proportional. So, okay, so this says an object has an acceleration of 6 meters per second squared. If the mass of the object were doubled with no change to the net force, then its new acceleration would be. So if we double the net force from 6 to 12 newtons, it's the mass. I'm all over the place today. So we'll stick with 6 newtons of force, and then we will double the mass to 2 kilograms. That is going to cut our answer, our acceleration, in half. Since we doubled the mass, we cut the acceleration in half, and the answer is going to be 3 meters per second squared. All righty. So this time it says that we have an object with an net force of acceleration of, this is what I get for trying to multitask, erasing things and talking at the same time. Object has an acceleration of 18 meters per second squared. If the mass of this object were cut in half, then its new acceleration would be. Okay. So this time it might make more sense. You could still plug it in like this. You could do 18 is equal to 18 over 1, kind of like I've been doing here. 18 newtons divided by 1 kilogram. Now it says that if we cut the mass in half, so now it actually becomes 0.5 kilograms and 18 newtons. And I do want you to be careful here. Make sure you actually plug this in your calculator, because when you divide by 0.5, it's the same thing as multiplying by 2. So this ends up being 36 meters per second squared. Might make more sense to do like if you just started it like this and you did, instead of 18 and 1, we did like 36 newtons divided by 2 kilograms. That way, when you cut it in half, it is not a weird number like that, a decimal. So 36 divided by 2, we cut the mass in half. So now it's 36 divided by 1, still comes out to be 36. Okay. So there is your answer. Okay. We'll do this last one here. So it says that we'll leave this equation in the way that it is. Okay, so if an object has an acceleration of 18 meters per second squared, the net force is cut in half, then its new acceleration would be. So I can leave this equation the same way. 36 divided by 2 is 18. And then if we cut the net force in half, so now it's 18 newtons divided by 2 kilograms, we can see that the answer is also cut in half. So we end up with 9 meters per second squared. Okay. All right, let's go ahead and head back to the main menu. We'll go over to the wizard level, and we'll do this one. A couple of these. All right, so this one says that the object has an acceleration of 12 meters per second squared. If the net force is doubled, what would the new acceleration be? So 12 meters per second squared is equal to 12 newtons divided by 1 kilogram. And again, I'm just making that up. You can make any equation that results in the answer being 12. It says the net force is doubled, so now it's going to be 24 newtons, and we keep the mass the same. And that's going to also double our acceleration here. Okay. So once you get the hang of this, do you have to write out the equation every single time? No. Once you understand what you're doing here, and you get that, hey, if the net force doubles, then I'm going to double the acceleration. You can just plug that answer in. I'm simply going through all these equations just to make sure that people understand that. But let's do a few where we just reason through it instead of looking at the equation. So this says an object has an acceleration of 18 meters per second squared. If the net force is tripled, then the new acceleration would be, well, remember that if the net force up here is times 3, then our acceleration is going to be times 3. So if the acceleration was originally 18, and then we triple it, it is going to be 54 meters per second squared. Okay, great, fantastic. Moving on. If an object has an acceleration of 6 meters per second squared and the net force is cut in half, then what will the new acceleration be? Well, if we divide our net force by 2, then we must divide our acceleration by 2. Right? So it's going to end up being 3 meters per second squared. Okay, an object has an acceleration of 12 meters per second squared. If the mass of this object was cut in half, then its new acceleration would be. So if we are going to cut the mass in half, so we're going to divide by 2 here, then that means that we are going to have to multiply our acceleration by 2 because they are inversely proportional. So if the original acceleration was 12 meters per second squared, then the new acceleration would be 24 meters per second squared. Okay. All right, we'll go ahead, and I think we've done plenty of examples there, so we'll go ahead and leave it right there and let you kind of finish that up on your own, okay? Because once you get the pattern down, once you understand that net force and acceleration are directly proportional, and that mass and acceleration are inversely proportional, this should go very quick for you. So make sure to let me know if you have any questions.